A modern accurate mass LCMS instrument can generate over 50,000 MSMS spectra per day, far more than a mass spectrometrist can analyze. To assist in reviewing this data, MathSpec has been developing tools to help scientists identify compounds from accurate mass LCMS data. Our tools are based on applying mathematics to accurate mass fragmentation data. We do not use traditional fragmentation rules. I'm Dan Sweeney from MathSpec Incorporated. In these 3 videos, I will briefly talk about using our similar partition screening software, called here SPS, on Amazon AWS. Our strategy is to use data-dependent acquisition and let the mass spectrometer and computers do the upfront work. When implementing DDA, the mass spectrometer is constantly checking each full scan spectrum to choose multiple precursor ions. The instrument does not, for example, choose only protonated analytes. But after the LCMS has been collected, our SPS software can review the full scan data to determine the addict of a selected precursor ion. SPS can also be used to summarize the data and to check whether any analytes in a new LCMS run have been seen before, even if those analytes have not yet been assigned to a structure. Our goal is to organize and archive your LCMS data in a relational database, while also checking the summarized data against a suspect screening database of about 240,000 small common molecules. This SPS application comes with an Access database template that has 8 useful queries built in. Users can also generate their own custom filters and queries to search their results. There are several steps. In this Part 1 video, I will discuss acquiring and preparing your data for SPS. 5 things are needed for this approach. Proteowizard software was developed originally for proteomics research. Several programs are available on the Proteowizard website, but the one that we need, which is called MSConvert, converts the proprietary mass spectral data formats used by the mass spectrometer vendors into formats that our SPS software can understand. It's freely available from Proteowizard. The SPS software that screens for common compounds, subtracts blanks, and summarizes all the data is installed on a server that you can launch on Amazon AWS whenever you want to use the SPS software. It is ready to go whenever you need it. An SCP application is needed to securely transfer your mass spectral data to your Amazon server and transfer your results back to your Windows desktop using a secure file transfer protocol. I recommend the widely used WinSCP, which is a free SCP client for Microsoft Windows. Lastly, Microsoft Excel and Microsoft Access are 2 widely used applications that come with Microsoft Office Professional. An optional Excel add-in to help identify unknown compounds is also available. Here's a slide of some hyperlinks that are useful for acquiring the 2 freely available programs at the top. An account with Amazon AWS is also needed, because there is a small charge for using the Amazon server with the SPS software. Amazon AWS has hundreds of other computer services available that you may also find useful in your work. The first step, acquiring good LCMS data, is the most important. MathSpec cannot help you with that. But here are 3 excellent references on setting up data-dependent acquisition parameters for LCMS. The 19 raw data files from the second reference will be used for this demo. These roughly 40,000 MSMS spectra are environmental surface water samples. SPS can handle both positive and negative ion data, but not data that is collected in alternating scans within the same run. The Access database adds some flexibility. For example, if you have some samples where a client is interested in every analyte and other samples where only the major analytes are important, the same DDA method can be used because the Access database can later filter the results by the maximum intensity of the precursor ions. 3 file naming conventions are suggested that will make the whole process much easier. LCMS injections of blanks should incorporate the string BLANK somewhere in the file name. This allows the SPS software on AWS to recognize blanks and then do the blank subtraction automatically on the AWS server. Likewise, LCMS runs of control samples should incorporate the string control, CONTROL, somewhere in the file name. This allows several built-in queries in the Access database to distinguish test samples from control samples. Windows permits file names with spaces, but please use an underscore instead of a space in your file names. To keep the video fairly short, I'm going to demonstrate MSConvert with only one sample file. Okay, I need to find the file. Bring this over here. And then I can add it in. I could have a large number of files. The output directory will be the same as the input directory unless you choose to change it. I'll do the full scan MS data first. So that is MS1, and the extension I want to use is MS1. Go with 32-bit, and I don't want to use any compression. So this part is pretty well done. If we go over here, the first thing I do is I remove anything that's in there already, and I start with the peak picking. I always start with that. And vendor is the algorithm that I want to use. And for full scan, it's MS1, if you will. So let me add that in. And then the second thing is a threshold peak filter. So this will save a certain number of the most intense ions in the full scan spectrum. I'm going to use a fairly high number, 500, because I would like to get the isotope data from this. Okay, I've got that, and then I can say start. So this was one LCMS run that was done in the DDA mode, and in DDA what you basically have is a series of cycles. So first the instrument does a full scan and picks out a few precursor ions if they're above a certain threshold, and then it selects those precursors and does MSMS on them, and then it repeats that cycle over and over. So what we're doing here is we're extracting the full scan data from the whole file. So that's done. Now I want to use the same file or files, and in this case I'm going to use MGF. It's a common proteomics output or generic file format, and this is the MSMS data. Use the same parameters here, and again I want to remove these and start over with peak picking, and I want vendor, and MSMS is like MS2 is another way of looking at it. So I'm going to add that, and then again we need a threshold, and the MSMS spectra, we don't have to worry about isotopes, so I'm just going to use 100 here. It's usually fairly clean. and again start. So the outputs are going to be in a text format with masses and then a tab and intensities. Although we're separating the full scan data here from the MSMS data, they're closely linked by the exact time at which these spectra were taken. So of course, we can relate one to the other. We also, the MGF format for the MSMS includes the mass of the selected precursor ion, but some of the vendors don't do a lock mass correction, and they don't apply that lock mass correction to the precursor ion. So to be safe, we take that mass from the full scan data, which is after the run, it's corrected for lock masses. Okay, that's done. At this point, I can I can close out MSConvert, and I want to go to the file. So this was the data, a Agilent data file. In this case, it was about it says 1.06 gigabytes. I'm going to select these two. I don't care which one is which, but they have the same name. And I want to send it to a compressed file. So that will tell the SPS that these two are a pair, if you will. The next thing, we don't see the suffixes in Windows, but I want to add a prefix, rename, and this was positive ion data, so I'm going to say POS dot. So we need that prefix of pos or NEG for negative, so that the SPS software will know whether the data that's being processed is positive or negative ion data. So that pretty much concludes the first section. We've got this data ready to put on a server in AWS. So the second video will be how to fire up that server and load the data in. Thank you for your attention.